Greetings, PreCalc. It's our Monday edition, November 6th. After our Monday class, we'll be solving trig equations that have multiple angles in them. The first one we're going to do is solve 2 cosine 3t minus 1 equals 0. And the end of the story, when you see the word solve, that means at the very end of the story, we want to find out what t equals. T equals blank for right now, but we're going to find some angles that make this a true statement. When we find our answers, when we plug them in for t, we'll get 2 cosine 3 times our answer minus 1, and it will equal 0. So let's see what this mystery angle could be. When we're solving a trig equation, we're going to get the expression with the with the trig function and the values to which the trig function are applied. We're going to get that all by itself. So the only difference between this one and the ones that you have seen previously is this angle is tripled right here, 3t. 2 cosine 3t minus 1 equals 0. So we're going to isolate the cosine of 3t, and then I'll show you how the 3 will mess with this problem. So I'm going to move the 1 to the other side. Then I'm going to divide by 2. This is an equation. You see an equal sign. So as long as I do each function on each side, I haven't changed any of the values. So here I added a 1 here and a 1 here. Then I divided by 2 here and divided by 2 here. So now I've isolated the cosine of 3t. And now I'm going to continue. I'm not going to, this is the spot where students often forget what I've taught them. And I'm going to divide, the students will forget what I've taught them and divide by 3 on both sides because of this 3. But this is inside the argument, we call it. That to which the cosine is applied is called the argument. It's applied to both the 3 and the t, so we cannot split it up. It's inviolable. Cannot be split up. We'll think of it as a marriage, which in the perfect world is inviolable. All right, so we're going to look at keeping the 3t together, and we're going to find out where on the unit circle this value 3t will equal 1, where the cosine of 3t will equal 1/2. So we're going to find a spot where 3t will have a cosine of 1/2. So looking at that, the cosine is 1/2 somewhere on one of these 6. Is it right there? 1/2 over square root of 3 over 2 up. Right, so this is 1/3 pi. 2 pi over 3 is one answer. And let's see if there's another spot. Over here the cosines are negative, and down here as well, so it must be over here. Is it right here? So here's when we go over 1/2 and down negative square root of 3 over 2. So we can see the first coordinate is positive 1/2. That's the cosine. So another place this happens is where 3t is, what's that one? 5 pi over 3. And notice I haven't restricted where we can look for these answers, so they're going to be forever. We can look at forever and ever. So this one, we can, why stop there? Let's go around again. So that would be plus 2 pi. Why stop there? We can go around again, and again, and again. So we indicate that with the n standing for any integer. And then the same thing for 5 pi over 3. Why stop there when we can go around and around and around? So we have an infinite number of answers stemming from 2 pi over 3 and 5 pi over 3. However, because now that we have found the place where the cosine equals 1/2, we can split this up. When it was part of the argument, part of the function cosine was applied to, then we couldn't split it up. But now we've already taken the cosine and found the spots where the cosine equaled 1/2. Now this 3 can be peeled away from the t. So it's no longer in the argument of a trig function, so I'm going to divide this side by 3 and this side by 3. When I do that, algebraically, this becomes 2 pi over 9, and this becomes 2 pi n over 3. So it does change our results. So that's what t has to equal. Down here, the same thing. Divide by 3. And this becomes 5 pi over 9 plus 2 pi n over 3. So those are our infinite number of answers. If I were to plug any of those into the original function, 2 cosine 3, let's say I do 2 pi 3 plus 2 pi. I plug that in and multiply it by 3, take the cosine of that, 2 times that, minus 1, I will get 0. As I will if I put in any version of these answers. So this tells me all of them right there. All right, so again, dealing with this tripled angle here, we couldn't split it up. We had to keep it together, and we had to isolate the cosine of it. And when we did that, we saw the cosine of 3t was 1/2. So we looked on the unit circle, and we saw that happened here and here, plus all the multiple spins. So now that I have found where the cosine of 3t equals 1/2, at this place and this place, I can then divide by 3. It's no longer part of the trigonometric argument. So there we go. And I want no arguments about it. All right, let's look at one more. 3 tangent x over 2 plus 3 equals 0. So once again, I'm not going to split up this. I'm going to keep this together and isolate the tangent and that to which the tangent is applied. This is called the argument. Everything else I'm going to peel away. So I'm going to move the 3 on this side and divide by 3. That leaves me minus 3 over 3, or tangent of x over 2 equals minus 1. Now, I'm wondering where the tangent of something equals negative 1. And I know tangents are negative in this quadrant and this quadrant. And if I look here, I get minus square root of 2 over 2 and positive square root of 2 over 2. Here, I get square root of 2 over 2 and minus square root of 2 over 2. So those, when you divide the second by the first, as tangent requires, you do get a negative 1 at these two spots. So where am I? 1/4, 2/4, 3 pi over 4, 4/4, 5/4, 6/4, 7 pi over 4 at those two spots. But notice the way they are situated, this one is directly across from this one. So therefore I learned a way that I can write those. So where is the tangent of this? equal minus 1, where this is 3 pi over 4 plus what? What can I add to this one to get this one and then all the spins thereafter? We can do that by noticing this is exactly pi radians away, half a circle. So we're going to keep doing that, pi n. Alright, so I wasn't allowed to get rid of this 2 until after I used my unit circle and took the tangent and found what tangent has an angle. What angle of the tangent of what angle has a tangent of -1? Said it. Alright, and we found that to be here. Now that I've found that, I can break. This was inviolable. So now that I found the places where the tangent equals -1, I can now split this up. So I'm going to multiply each side by 2 to get x all by itself. And when I do that, this gets multiplied by 2, and I get 6 pi over 4 plus 2 pi n. And that reduces to 3 pi over 2 plus 2 pi n. Those are all the answers that will fit into this expression and create a 0. Alright, those are 2 examples, and as usual, it doesn't do me much good to keep showing you more and more examples. The way you learn it is to do them yourselves. So you can come in bright-tailed and bright-eyed and bushy-tailed, ready to do that. So till then, PreCalc, I bid you good night.